So hello everyone, this is Akshay and today we're going to see a very important question of the DP playlist, that is the longest increasing subsequence. So this is the question here on the GFG I have solved in 2021 like during my placement season. So let us may solve this question again so that can help you guys as well. So let's get started. But before proceeding ahead, if you're on the channel, please like, share, and subscribe so that we can learn, maintain, and grow a streak together. And hit the bell icon to get the regular updates. ओके सो लेट अस सी फर्स्ट ऑफ ऑल कि इनपुट और आउटपुट आ कैसे रहा यार। तो लेट्स से हमारे पास एलिमेंट है 3 4 2 8 10। तो हमें सबसे पहले समझते हैं सब सीक्वेंस क्या। मैंने बहुत बता दिया बट एक बार फिर से बताया। तो सब सीक्वेंस का मतलब क्या होता है, अपन दो चीजें कंफ्यूज हो जाते हैं कभी कभी, सबस्ट्रिंग और सबस्ट्रिंग का क्या मतलब है कि यू नीड टू पिक अप द कंटिन्यूअस एलिमेंट्स, राइट। सब सीक्वेंस में ऐसा नहीं है, आपको बस एक ऑर्डर मेंटेन करना है, दैट इज फ्रॉम लेफ्ट टू राइट, और आप बीच के एलिमेंट स्किप कर सकते हो। जैसे मैं अगर उठाता हूं 10 8 एंड 20, देन दैट इज अ सब सीक्वेंस, राइट, बट दैट इज नॉट अ सबस्ट्रिंग, करेक्ट। ठीक है ओके, तो इसे डिलीट करते हैं। आई होप आपको बात समझ में आ गई हो एंड लेट अस प्रोसीड एट। सो 3 4 2 8 हमें इसी में लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस, एक तो उस सबसीक्वेंस का साइज सबसे लॉन्गेस्ट होना चाहिए और इंक्रीजिंग होना चाहिए। तो अगर आप देखो इसमें, तो मैं कौन से एलिमेंट्स को उठा सकता हूं यहाँ पे। मैं कहता हूं कि लेट अस पिक दिस 3 देन 4 8 एंड 10, राइट। तो ये सबसे लॉन्गेस्ट भी होगा और इंक्रीजिंग भी है। 3 से बड़ा 4, 4 से बड़ा 8, 8 से बड़ा 10, ये होता है इंक्रीजिंग, राइट। मैं 2 8 10 भी एक इंक्रीजिंग सबसीक्वेंस है, 2 8 एंड 10, राइट। और सबसीक्वेंस आप स्किप कर भी सकते हो, नहीं भी कर सकते, वो आपकी चॉइस है, राइट। सो 2 8 10 इज ऑल्सो सबसीक्वेंस बट दैट इज नॉट द लॉन्गेस्ट वन, दैट इज नॉट द लॉन्गेस्ट इंक्रीजिंग, करेक्ट। ठीक है, अब इसमें आप देखो इसमें क्या आंसर हो सकता है। मैं आउटपुट 5 है, तो मतलब कौन सी एलिमेंट को उठाया गया, सबसे पहले 4 हमने लिया होगा, देन 5 8 11 एंड 20, दैट्स द लॉन्गेस्ट वन। यू कैन ऑल्सो आप ये भी ले सकते थे कि 6 5 8 11 20, राइट। 6 5 8, इसका लेंथ 5 हो जाता है, राइट। तो वो हो सकता है एक इनपुट के मल्टीपल आंसर्स भी हों, बट यहाँ पे हमें सिर्फ लेंथ प्रिंट करना है, ना कि हमें एक्चुअल एलिमेंट्स प्रिंट करना है, राइट। तो इसकी पहली अप्रोच क्या हो जाएगी यार, कि हम सारे सब सीक्वेंस फॉर्म कर लें, हम रिकर्जन का यूज कर लें एंड व्हाट कैन आई से इज जनरेट all subsequence. So I am writing subsequence as ss, okay, ss। तो जनरेट और सबसीक्वेंस में क्या टाइम लग जाएगा, 2 पावर n, और उसके बाद हर एक सबसीक्वेंस हमें ट्रैवर्स करके देखना पड़ेगा कि वो लॉन्गेस्ट, मतलब वो इंक्रीजिंग है, नहीं इंक्रीजिंग है तो हमें मैक्स को ट्रैक करना पड़ेगा, राइट। तो वो तो बहुत लेंदी हो जाएगा, राइट। 2 पावर n तो मतलब डेफिनेटली टच होने वाला है सिर्फ फॉर्म होने में, राइट। तो अगर आप कंस्ट्रेंट देखो, ये अगर आप अपनी कंस्ट्रेंट देखें यहाँ पे, n जो है वो 10 पावर 4 है, राइट। तो अगर आप 2 10 पावर 4 करोगे तो ये डेफिनेटली 10 पावर 8 हो जाएगा और ये हमें दे देगा TLE, राइट। सो इवन इफ आवर कोड एंड अप्रोच विल बी राइट यूजिंग दिस मेथड 1, बट हमें यहाँ पे TLE आ जाए, राइट। तो हम इस मेथड को स्किप करते हैं क्योंकि जनरेटिंग ऑल सबसीक्वेंस हमने बहुत बार कवर किया, व्हाई टू डू इट अगेन एंड मेक दिस वीडियो लेंदी, राइट। मेथड 2 क्या है हमारे पास, मेथड 2 हमारे पास ये है कि हम कुछ ऐसा सोचे, थिंक ऑफ अ सॉल्यूशन व्हिच हैज ओवरलैपिंग सब प्रॉब्लम्स, ओवरलैपिंग सब प्रॉब्लम्स। सो डोंट माइंड माई हैंड राइटिंग गाइज, यू कैन, आप पेन और पेपर साथ में लेके बैठो, जो मैं लिख रहा हूँ अपने पेन पेपर में लिखो, आपको दिक्कत नहीं होगी, राइट। इसका क्या मतलब है, लेट्स से हम एक एग्जांपल लेते हैं 3 4, हाँ कहाँ गया मेरा पॉइंटर, हाँ लेट्स से हम एग्जांपल लेते हैं 3 4 2 8 एंड देन 10 5 एंड 1, राइट। लेट्स से हम ये लेते हैं। अगर मैं कहूँ कि सिर्फ इस पॉइंट तक, लेट्स से मैं लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस LSI ऑफ 0 पॉइंट करता हूँ, अगर इस पॉइंट तक लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस क्या होगा, तो मैं कहूँगा सिर्फ 3, जिसकी लेंथ क्या होगी 1। अगर मैं कहूँ LSI 1 पे, राइट, दैट इज आई एम कंसिडरिंग दीज 2 एलिमेंट्स 3 एंड 4। तो अगर आप देखो तो 3 और 4 हमारा एक लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस होगा इफ आई एम कंसिडरिंग जस्ट द एलिमेंट्स टिल 0 to 1 इंडेक्स, राइट। तो हमारा आंसर हो गया 2। सिमिलरली अगर आप हम चेक करें, ठीक है, तो अगर हम LSI ऑफ 2 को देखें, अब जहाँ पे हम वी आर कंसिडरिंग द फर्स्ट 3 एलिमेंट्स, तब यहाँ पे हम लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस कह सकते हैं, बट क्या कह सकते हैं, इट इज स्टिल अगेन 2, राइट। बट यहाँ पे एक कंस्ट्रेंट क्या होगा कि हमें इस जिस इंडेक्स से हम चेक कर रहे हैं, दैट वी नीड टू इंक्लूड दैट एलिमेंट एज वेल। तो अगर हम 2 को इंक्लूड करते हैं तो यहाँ पे क्या आंसर हो जाएगा, सिर्फ 2, राइट। अगर हम 3 से स्टार्ट करेंगे तो 2 छोटा हो जाएगा, वी कैन नॉट टेक इट, देन इफ यू स्टार्ट फ्रॉम 4 देन वी हैव अनदर 2 एंड अगेन वी कैन नॉट टेक इट, राइट। तो यहाँ पे LSI हो जाएगा अगेन लेंथ ऑफ 1, करेक्ट। फिर LSI ऑफ 3 पे चलते हैं, इंडेक्स 3 पे। यहाँ पे मैं इंडेक्स लिख देता हूँ ताकि हमें इजी हो समझने में। सो 0 1 2 3 4 5 एंड 6। सो LSI ऑफ 3 इज नथिंग बट वी आर हैविंग द एलिमेंट 8 एंड वी कैन कंसिडर ऑल द एलिमेंट्स बिहाइंड 8 एज वेल, राइट। बट हमें 8 को इंक्लूड करना ही करना है, तो मैं क्या कर सकता हूँ, 3 4 एंड 8, राइट। आई कैन कंसिडर एन एलिमेंट द सब सीक्वेंस 3 4 एंड 8 और इसकी LSI क्या हो जाएगा, लेंथ क्या हो गया 3। देन अगेन let's proceed ahead like this. So LSI of 4 I have to include 10 as well. तो मैं क्या ले सकता हूँ यहाँ पे, I can start from 3, I can take 4 and then 8 and then 10, then definitely my length will be nothing but 4. LSI of 5 देख लेते हैं, LS of 5 में we can take the element starting from 3 to 5 and we have to consider this fifth element as well, right? That itself is pointing to 5. So what is the subsequence we can take here? So we can take 3, 4, 5 and we need to make sure that's the longest one as well. So the length of this subsequence would be 3, correct? Let us proceed ahead with the next iteration and then LSI of 6 would be nothing but we have to include this first element, right? This sixth index element and that itself is 1. So we cannot take any element behind this because every element behind 1 is greater than it, right? So definitely यहाँ पे एक ही subsequence possible होगा, that is a 1 if we have a condition that we must include that particular index as well, right? तो यहाँ पे 1 हो गया. अगर आप देखो यहाँ पे तो if we are trying to find, अगर हमने इसका इन सारे possibilities का max निकाल लिया, right? 1 2 1 3 4 3 1. अगर मैं देखूँ max, तो max is 4. That would be our answer. That would be our answer. So I can write that we have a function, let's say continuing from I equals to 0 to n minus 1 और हमें LIS के I का हमें max चाहिए, right? LIS के I का, right? I index पे तो 4 हो जाएगा definitely, right? And that is our answer for this particular sub problem. We have the answer as 4, correct? Okay. Okay, now please pause this video and try to code this or pseudocode this approach first of all, and then try to code this approach. I will write pseudocode myself and then I'll explain you a quick dry run, and then we can go to the code editor. Okay, so that's the pseudocode here I have written, that we need a nested for loop. The first for loop that will strive for I equals to 0 to I less than n, और हम सारे I के लिए हम एक particular jth index पे जाएंगे starting from 0 to less than I. चलो एक इसका dry run देखते हैं, आपको hopefully ये बात समझ में आने लग जाएगी, right? So for I equals to 0, what will happen? We have the element as 3, right? We have the element as 3, but we know what if there is a if there is only one element in our array, then definitely the LIS would be equals to 1, right? So that is why we have started. We will be starting I from I equals to 1, and the element here would be nothing but 3. These are the elements, right? So element here would be nothing but 4. Okay, actually 4. So we need to compare the array of j if it is less than equals to less than array of I, right? So array of j starts from 0 to less than I, right? So what is the first element here? The element here is 3. We need to compare that which one is the larger. So definitely array of I is greater, right? So that means कि अगर हम इस point पे थे, राइट तो यहाँ पे जो भी एलिमेंट था अपने नेक्स्ट प्रीसीडिंग एलिमेंट से बड़ा है, देन डेफिनेटली LIS भी एक बढ़ेगा, राइट? वी नीड टू इंक्रीमेंट. सो दैट्स व्हाई वी हैव रिटन दैट LIS ऑफ I इज नथिंग बट मैक्सिमम ऑफ, इफ आई राइट इट फॉर यू, मैक्सिमम ऑफ, हमने यहाँ पे सबसे पहले 1 पुट किया, मैक्सिमम ऑफ 1 कॉमा LIS ऑफ जिस एलिमेंट्स हमने कंपेयर किया, इसका आंसर तो हमें पता है, इस डीपी से निकाल लेंगे. दिस LIS इज नथिंग बट द DP array, राइट? हम पिछले प्रॉब्लम्स को यूज करते जा रहे हैं, तो मैं इसको यूज करूंगा एंड आई विल जस्ट से दैट LIS ऑफ दिस पर्टिकुलर इस ये एलिमेंट का इंडेक्स 0 है, तो वहां से वैल्यू को उठाओ एंड देन डू +1, राइट? सो डेफिनेटली आई कैन से नाउ द LIS इज 2 एंड नाउ आई विल अपडेट दिस एज 2, करेक्ट? ठीक है, अब I equals to 2 पे चलते हैं. I equals to 2 पे चलेंगे तो वी हैव द एलिमेंट 2, right? So this is the 2 and then we need to iterate for 0 to less than this 2, right? So the elements we need to compare it, the first 3 and the second is 4. Now I can clearly see that my array of I is not greater than my array of j, correct? So यहाँ पे increment नहीं होगा, LIS नहीं बढ़ेगी and similarly नीचे भी LIS नहीं बढ़ेगी, राइट? क्योंकि हम किसको कंपेयर कर रहे हैं यार, ये 2 है, इस 2 को हम इस 3 से कंपेयर कर रहे हैं और 4 से कंपेयर कर रहे हैं, राइट? हम चाहते हैं कि इंक्रीजिंग रहे हमेशा, बट जिससे हम कंपेयर कर रहे हैं वो इटसेल्फ इज द स्मॉलर एलिमेंट दैट इट्स प्रीवियस बिहाइंड, तो हम इसलिए दैट इज व्हाई वी विल नॉट इंक्रीमेंट द LIS. Okay, let's get ahead with the third index now. So in the third index, if you see that the array of I is pointing to 8, now again we need to iterate for j will comes from 0 to less than 3, right? So let us write the element. So for the 0th index, it is 3, then 4, and then 2. I am comparing it with 8. So for all the cases, so let's see for the first iteration, 3 is less than 8, right? Then definitely LIS would be updated for this 8, right? So for 2, it would be nothing but just 1, right? क्योंकि I equals to 2 के लिए हम तो कह सकते हैं एक subsequence तो possible है ना 3 का, right? The element itself, that is 2, correct? ठीक है, अब यहाँ पे array of I वो j से बड़ा है, तो यहाँ पे अब हम अपडेट करेंगे अपने. So I will write, यहाँ पे सबसे पहले हमने 1 लिखा, right? उसके बाद हमने लिखा max of 1, LIS of 3. LIS of 3 क्या है, उसमें एक +1 कर दो क्योंकि ये 8 उसमें ऐड हो जाएगा, राइट? तो LIS of 3 इफ यू विल ये 3 जो है ये इंडेक्स क्या है इसका 0, so LIS of 0 actually, right? This is the jth index, so j equals to 0, 1 and 2, correct? And this is nothing but array of j and this is nothing but array of I. ठीक है, तो LIS of 0 + 1, तो 0 पे क्या है वैल्यू 1, राइट? तो यहाँ पे अपडेट हो गया एज 2, 1 + 1 2. ठीक है, अब ये फिर से बड़ा था, तो आई विल अगेन सी मैक्स ऑफ the previous LIS is already pointing to 2, right? तो मैं कहूँगा 2 comma, right? 2 comma, और मैं इसको क्या कर दूंगा 2 से चेंज भी कर दूंगा यहाँ पे. Now I will say 2 comma LIS of this first, LIS of first पे क्या है 2, right? तो 2 plus 1 is nothing but 3. तो मैं इसको अपडेट कर दूंगा 3 से, right? Now I will again check max of now previously LIS क्या हो चुका है 3 already. So I will compare with LIS of index 2. Index 2 पे क्या value present है 1. So it would be 1 plus 1. So 3 comma 2 में max क्या है 3. So again it will be updated as 3. I hope we are at the same page here now. Let us do for the last iteration. So for I equals to 4, we have the element 10, right? So this is the array of I is 10, 10, 10, 10. I need to compare it with the j starting from 0, 1, 2 till less than 4, right? So what are the elements here? 3, 4, 2, and 8. Right? So in all the cases you can see that the 10 is greater, right? So first of all what will happen here, we'll compare the max of, यहाँ पे हम पहले 1 लिखेंगे क्योंकि 10 एक ऐसा subsequence है जिसमें हम बोल रहे हैं कि इसका length 1 तो होना ही चाहिए at least, right? So I will compare again max of 1 comma LIS of 3 पे चलो क्या है, इस 3 का index है 0, LIS of 0 क्या है 1. So I will say 1 plus 1, the max here will be updated as 2, LIS of 4 will be updated as 2, right? Then I will again compare the max of the previous LIS, that is 2 already, and we will compare with the LIS of 1. That's 2 there. So 2 plus 1, which will give you as 3, right? So it will be updated as 3 now. Again, let us check for 2 more iterations. So the maximum of, it's again 10 is greater than 2. So we have to check it again. So the maximum of the existing LIS is what? 3. So 3 comma, the index is 2, right? So LIS of 2 is pointing to 1. So it would be 3 comma 1 plus 1, but again 3 would be greater, right? 3 would be prevailing. वापस से it's the last iteration. Let us complete the pace. ठीक है. So LIS of already we have 3 there. Then LIS of index 3. What is the LIS of index 3? It is 3, right? So I will say 3 plus 1, which will give me as 4, right? So finally it has been updated to 4, and the elements you can clearly see is that we can take 3, 4, 8 and 10 for this particular thing, right? We can clearly take that. Yes, and that is why for this particular now we have the LIS array. First of all, there is a second step as well. In the LIS array, what you have, what are the elements we have here? You have 1, then again 2, then 1, 3 and 4, right? With the indexes 0, 1, 2, 3, 4, right? हमें इनका जो max है वो हमें return करना है, right? That's what I have return the max of LIS of I. You can see that the 4 would be the answer, and what would be the actual, if we see it manually, तो हम कौन से subsequence को consider कर रहे हैं? हम कर रहे हैं 3 and then 4, then 8 and 10. Right, this would be the longest increasing subsequence of this particular input. Now please pause this video and try to code this approach by yourself in the code editor, and then we can proceed ahead with the actual code. So meanwhile, before proceeding ahead, what would be the time complexity for this particular program? The time complexity would be that we are using a for loop here, so it would be definitely O of n for the first for loop and definitely O of n. This I, इसका worst case क्या हो सकता है? ये worst case ये होगा कि n times चलेगा, right? n minus 1 times चलेगा, so that is why इसका भी n ही लेंगे हम लोग. So O of n square, and space complexity that we are using a DP array on the name of LIS, so it would be say O of n, correct? Let us see the time complexity, or let's see the constraint first, that this solution will get submitted or not. So n is nothing but 10 power 4, and we are using n square solution, so it is hitting the boundary condition of 10 power 8. So definitely for some of the test cases, this approach will give us the TLE. Let us verify that as well, and then we can proceed ahead with the optimized one. Okay, so that's the Java code here. I don't think a walkthrough is required. I've explained you in a very detail in the drawer and in the open board. So if you're not able to understand still yet, please revert back to the video and watch it again, right? But definitely I'll give you a very quick walkthrough. So this is the first for loop. We are initializing for each and every index that the LIS minimum would be 1, because we will be considering that particular element जो हमारे subsequence से part होगा. अगर पीछे सारे elements छोटे भी हैं तो वो जिस particular element पे हैं वो at least एक subsequence होगा ही. So that would be the at least answer would be 1 for each and every index. That is why we are appointing 1 here, and then we are checking कि अगर previous elements अगर इससे बड़े हैं तो keep on increasing the LIS, and we are using पीछे के problems, पीछे के index पे जो भी index के elements हैं हम उनके value को use कर रहे हैं, use from this DP array, correct? Great. And at the last, or not at the last, while filling the LIS for each and every entry, we are maintaining the max result for that, and we are just returning that particular variable. That is the result here. Let us hit the submit button. But definitely, I'm sure since the time complexity is n square, that is hitting the bound of 10 power 8, then some of the test cases must stuck here, because that 10 power 8 logic holds everywhere. We need to code it in less than 10 per iteration to solve the problem. So for the 4 cases, you can see it has hit the TLE. Let us see the optimized approach now. What can we do ahead? Okay, so the method 2 is, this video may be thoda sa long ho sakta hai yaar, but let us sit tight. So LIS, the second approach would be take NlogN, right? How is that? We will use binary search here, right? In the array, or let's say in the auxiliary array, because the array may be unsorted, right? So let us see how that can be done. So the idea here is that we will have to store minimum possible tail value for every LIS length. Just keep on listening, it will make sense to you with time, right? So let us say we have the elements as 800, 150, 10, 12, 14 and 10, right? So जब भी हम left to right जा रहे हैं, and as soon as we are finding that the value is increasing, then we do not have to do anything. But as soon as we get a violation, as you can see that this 800 and 150, there is no violation, right? So we will just keep on iterating, right? But at the end of it, I can clearly see that the value coming here is 10, right? And that is the point of our violation. तो हम इसके लिए बाइनरी सर्च लाएंगे यहाँ पर. वो कैसे होगा? यहाँ पे 150 लिख दिया हमने. हम 10 को सर्च करेंगे कि इस कौन से पर्टिकुलर इस इंडेक्स में हम कहाँ पे उसे प्लेस कर सकते थे, और क्योंकि ये सॉर्टेड है तो हम यहाँ पे बाइनरी सर्च डेफिनेटली लगा सकते हैं. सो माय नेक्स्ट एंट्री वुड बी 8, 10 एंड 150. करेक्ट, 10 यहीं पे प्लेस होगा. अब देखो नेक्स्ट एलिमेंट क्या है? 12. अगेन 12 इज ग्रेटर देन माई less than my 150, right? So again I need to do the binary search on this particular array. तो इसका array update क्या हो जाएगा? 8, 10 and then 12. The next element is 14, which is less than my this tail, right? So I will just add that 14 here. But now the next element is 110 again is greater than my tail, so I will add 110 here as well, right? And if you see that this is nothing but our LIS length, you just need to return the tail dot length in the Java and you can get your answer. If you see that if I dry run it for you, then what's the longest subsequence here is that we can take, let's say 100, or what we can take here. Clearly if you see that we can take 8, 10, 12, then 14 and then 110, right? Definitely this would be our answer, and that is how we are getting the 5 as answer in this length as well. What would be the corner cases? Or let us do a one more dry run. So let us say you have the elements as now 8, 2, 3, 1 and 4, right? So the first element would be pushed. Now the second element come 2, then definitely that is less than our tail element. So again the binary search will happen and 2 would be replaced here, right? Then the next element come 3, which is greater than our tail. We just need to push it and move ahead. Next element comes 1, which is less than our tail. So I need to fix it. So it would be 1 and then 3. Now the next element is 4, so nothing, we need to just add it and proceed ahead. So what would be the corner cases for this one? Corner cases की हमारे पास कोई चीज जैसे increasing हो जाए, decreasing हो जाए, या फिर let's say हमारे पास decreasing हो जाए, right? So in this case what will happen? First 10 will come, then the next element 5 will have to again do the binary search to fix it, so it would be 5 here, and then again the next element 3, again you have to do a binary search because that particular element is less than your tail element. बट यहाँ पे देखो अगर इंक्रीजिंग है तो कुछ नहीं करना है, मैं 10 ऐड किया पे 20 भी कोई दिक्कत नहीं देगा. दिस इज फॉलोइंग द इंक्रीजिंग ऑर्डर देन 10, 20 and 30, right? And that's it. You just need to return the tail dot length. As you can see that here the length of the LIS would be actually of length 3, that is 10, 20 and 30. And for here you can clearly see that the LIS would be just 1, either 10. You can take the answer as either 10 or 5 or 3, right? But the length again would be one for each and every case. Now please pause this video and try to code this approach, because I will not show you pseudocode. It is a very, what to say, after getting a great understanding, you can definitely do this approach in your code editor once you have a good understanding of binary search. Great. Please pause this video now and try to code this approach, and then I will show you a code walkthrough in the code editor. Okay, let's get started with the code. That's a very simple code. Let me give a very quick code walkthrough on this. Okay, so what we have here, that we have made an answer array of length n, definitely, right? And then what we need to do ahead, so this answer array is nothing but our tail array, right, where we will store our elements here, right? Okay, so the first element we have the first index पे जो element होगा वो कौन सा होगा? जो given array का जो elements होगा, right? Now we have a for loop here and we are checking if the subsequent elements, right, is greater than my previous elements, correct? then तो हम कहाँ शुरू करेंगे, हम सेकंड इंडेक्स से शुरू करेंगे, दैट इज सिंस अ जीरो बेस्ड इंडेक्सिंग, तो सेकंड इंडेक्स क्या होगा 1, राइट. उसके जस्ट पीछे हम चेक करेंगे वो एलिमेंट छोटा है बड़ा, राइट. सो द करंट इंडेक्स वी आर एट array of I and then we are also maintaining one index that is len using len to iterate in our tail array, and len is nothing but for the first one it would be 0, so that's why we have written len minus 1. So if the tail end is the last tail, if it is lesser than our current element, right, then definitely there is a no violation, right. You just add that particular current element in our new tail array, right, in the tail array at the last index, that's what we have done, and just increment the index, correct. If that's not the case, then you need to fix it. How you will fix it? You will just call a binary search. We have named the function as a seal index. We'll pass the tail array here, that is we have named it as answer here. Then the lower index, the higher index where we need to do the binary search, right. This higher index is nothing but the index where the tail ends, correct. And this array of I is nothing but this is the actual element which we need to fix in using the binary search, correct. Once we get that index, how we are getting that index? So how we are getting that index, let me show you a very quick dry run for that. So let us assume that we have some elements, let's say 3, 4 and 20, right. So till 3 and 4 there would be no violation. In the second index where the value is 20, there would be a violation and we need to fix it, correct. So where we can fix that particular thing, so that is why we have this a binary search where L would be nothing but 0, right, and R would be nothing but So L would be 0. We have to do a binary search in this particular index, that is 0 to 1, and R would be nothing but 1. If we find the mid element, that will be 0 plus 1 by 2, that will give us 1. 0, right? 1 by 2 will give you 0. So we will compare if this 3 is greater than equals to our target, that is 20. It is not, right? Then what we need to do, we will push our L to m plus 1. L equals to m plus 1. Correct, because all the elements at this point from 0 to m would be obviously lesser than this 20, right. So that is why we need to do a binary search in the right hand side, and L equals to m plus 1 will give you as 2, right. Now L and R matches, no sorry, it would give you as 1, right. So now the L and R is equal and we will just return this one index. So that means our while loop will run from L less than equals to R. This is a basic binary search we are doing. I don't think this walkthrough was also required, but still I have given you a very quick dry run for the binary search. That is what we have written here. While L is less than R, we are finding the mid index. We are checking if that target element is greater than equals to X, then that means, okay, if that target index is greater than equals to X, right?